Now, you might have heard of Z, T, F, and all these different test statistics. And so what do they mean? And so the short answer is that essentially the test statistic is sort of a tool that we use to reject hypotheses. And the next video is about hypothesis testing and just the logic behind it and how to use it. But in this video, I'm just going to talk about what a test statistic is, especially the more common ones. And so first, let's talk about Z. Z, essentially, the English interpretation of Z. If somebody were to say that the Z is 1.7, what does that mean? What should come to mind when you hear that? Well, in English, Z is basically, and T as well, Z and T are basically so Z and T are essentially both the number of standard deviations away from the mean that value is. So the difference, by the way, between them is Z is just what it is when you use sigma, and T is what it's called when you use your sample standard deviation S. That's the only difference. Other than that, they mean the same thing. So the formula is literally, well, I guess before the formula, let's just think about it. If I were to say that the mean is, let's say, 50, and that the standard deviation is, let's say, 10, and if I were to say that my value, my x, is 65, and if I were to ask you, what is the z corresponding to that x value? Well, let's see. It's basically saying, yeah, how many standard deviations away from the mean? Well, first of all, to answer that, we're going to first say, how far away from the mean are you? Well, 50 to 65, well, you're 15 units away from the mean, right? If the mean is here at 50, you're here at 65, you're 15 units away. But each standard deviation is 10, so how many of those 10s fit in over here? Well, basically 1.5, right? So z is 1.5. So what's the formula? If we wanted a formula, we would say that z is literally your x minus the mean, so that's how far away you are, divided by sigma. And similarly, t is, divided by s. Now, that being said, this is essentially something that could be negative or positive, right? Because if you're below the mean, if the mean is 50 but you're only at 30, well then this is 30 minus 50, you're 20 below the mean, and so if your standard deviation is still 10, then your z is negative 2 because you're 2 of those 10s below the mean. So if you look at the distribution of all z's in the world, z and t average out to 0 because the mean is literally 0 away from the mean, right? So the mean of your population is going to have a z value of 0, and there's going to be as many positive as negative, and it's going to be symmetric. So that's your z and t. And so this is so notice a normal distribution is this usual bell curve. And so specifically when it's normal with a mean of 0 and a standard deviation of 1 here, because if it's 1, that literally means you're 1 standard deviation of the mean. This is what we call a standard normal distribution. So the standard normal distribution is literally the z distribution. So that's all that is. Z is the standard normal distribution. Now, when we're talking about test statistics in particular, the context is usually not just finding the z for an individual person, like how many standard deviations away from the mean are you, but rather a sample mean. So basically, if the x bar, my average in my sample was 40, and the population's mean is, let's say, 50, I know I'm below the mean, and let's say the standard deviation is 10, then, and let's say the sample size is 25. Well, basically, if I want to find your z-score, technically, t-score because I have s rather than sigma. Yeah, so again, that's the only difference between z and t, is whether you're using s or sigma. So if I want to find my test statistic t over here, again, how many standard deviations away from the mean are you? But here, the concept that you're measuring is not a person, but rather an average. And remember, the standard deviation of x bar is the standard error. So now this brings us to the main formula for z and for t. For z and for t, the main formula is literally just the difference, like your x bar minus mu over standard error, right? So that's sort of the main formula. It's just how many standard errors away from the mean are you? Because again, standard error is the standard deviation when the thing in question is a sample average. So how many standard errors away from the mean are you? So in this case, your t is going to be, let's see, 40 minus 50, so that's how far away from the mean you are, divided by each standard error. But notice each standard error, the formula for standard error is s over root n. So that's going to be 10 over root 25. So, you could figure that out. Root 25, that's 5. 10 over 5 is 2. And then you could, negative 10 over 2. That's going to be 5. So your t is negative 5. So that means you're 5 standard errors below the mean. So that's pretty far below the mean. Usually anything more than like 2 standard errors away from the mean is pretty much rare. So if your z or t value, if the magnitude is more than 2 away, like 5, then it's usually considered pretty far away. Finally, f is a test statistic as well. Unlike z and t, f can only ever be a positive number. But again, the math, the details aren't really that crucial for most purposes. But the whole point is, when do you use f versus t or z? And you use f whenever there's multiple things that you're testing rather than one thing at a time. So you just use this for multiple things that you're trying to test for. And that's when you use that. And the bigger that is, the rarer it is, right? So the bigger that is, the further away from the means those values are.